Hello, this is Ryan Honeycutt. Today I am going to talk about domain-driven design. I will discuss what it is, why it is important, and also discuss some criticisms of the approach. Domain-driven design, or DDD for short, is an approach to software engineering that focuses on a deep understanding of the core business concepts before any architecture is designed or any code is written. The DDD approach was introduced by Eric Evans in his book, Domain-Driven Design, Tackling Complexity in the Heart of Software. Domain-driven design has three core concepts that are key to understanding. First is the idea of the domain. Simply put, the domain is the subject area. For instance, banking, insurance, or medical. The bounded context is the specific context in which we define our terms. For instance, a customer for a bank will have different meaning than a customer for a medical provider. Last but not least is the concept of ubiquitous language. This language is based on and driven by the business context and should be reflected in the code. The domain refers to the business domain, or subject area around which application logic revolves. During the define phase of the domain-driven design process, it is imperative that the business provide subject area expertise. Without that business side expertise, too many assumptions will be made, and we all know what it means to assume. During the process, large and complicated domains are broken down into easier to digest subdomains. Some examples of a domain might be banking at a high level, with subdomains such as customer and account. Following the domain is the bounded context. The bounded context is all about language. Context is important because words can have multiple meanings based on who you are speaking to. A customer at a bank is different and will have different attributes than a customer of a hospital. While there will be overlap, the bounded context in which a domain or subdomain exists is crucial to understanding the meaning. Another important aspect of bounded context is how it drives development. The context defines the implementation of the logic. In river crossing, for example, each variation of the game has a boat. The boat could be a domain, and the context is which variation of the game, farmer or monster, for instance. The language defines the implementation of the boat. It behaves differently in the different versions of the game. The domain, along with the bounded context, help us define a ubiquitous language. The language we define enables communication between technical and business teams, as well as communication within the technical teams. In the context of software engineering, and especially object-oriented programming, the language drives the structure of the code to match the business language. Class names, variables, and methods should all match the business domain. A simple example of this might be a customer domain, with actions to get a customer or update a customer's address in business terms. In our code, we might have a class called customer with method names, get customer, and update address. In software engineering, there's always a model. Whether it is an entity relationship diagram for a database or a class diagram for object-oriented code, there's always an underlying model for the system. Software development is easier when the internal model is in harmony with the business model. When the two are in harmony, the internal layout of the code base just makes more sense. The code, classes, variables, and methods all follow a pattern. This lends itself to easier maintenance and makes it easier to onboard new developers. Software exists to solve a business problem. Whether that problem is a banking application providing access to customer accounts or a video game allowing customers to explore a fantasy world. Domain-driven design seeks to understand the domain that contains that problem space. As you may guess, the domain defines the context within which that software must exist. A simple bank domain may have a customer, account, and transactions. Take a few minutes to think about a software project you are working on. What's your domain look like? Domain-driven design is not meant for every software project. DDD is most appropriate and most needed in large, complicated systems. As a software engineer, it would be very difficult to build a banking app from scratch. But DDD allows us to decompose the bank domain into more manageable chunks. Which brings us to the question of why to use domain-driven design. First and foremost, domain-driven design allows for improved communication within and across teams. The language that comes out of the discovery of the domain model helps to prevent misunderstanding between business and delivery teams. On the technical side of the aisle, the model produced during the design phase will map directly into the code, from classes mapping up to domains and methods mapping to actions within that domain. This allows the code to be self-documenting, making it easier to maintain and onboard new developers. There's no doubt that domain-driven design is not for every initiative. As we know, time is money. Depending on the complexity of the domain, it can take weeks or months to properly vet out a domain model, which leads to domain-driven design costing more upfront. But I would argue, in complex systems, the extra time spent upfront will result in lower maintenance costs going forward and ultimately reduce the overall cost of a project. Writing software is a complex business. While individual developers may be great at their job, understanding the context within which the software exists focuses the effort on solving the business problem and, in return, providing business value. Domain-driven design brings a focus on the business domain, defining a context and language for the software engineering effort. The language and context developed during the DDD process drives development, enhances understanding, and enables clear communication, ultimately increasing the odds of a successful implementation and deployment of complex systems.